Okay, so we're back for the second session after a great keynote. And this session is going to be moderated by Zach Kermis. In general, each session of the workshop has a different moderator, and that moderator will organize the lightning presentations and then moderate the panel discussion that follows. So you'll have a lot of opportunity to ask questions after the lightning presentations finish. Okay, Zach.
All right, so hi everyone. Bear with me a little bit. We did a little bit of changes at the last minute, so I'm winging it just a little bit, but I suppose I think we all have the ability to share the screen on our own, so I would just go down the list with the lightning panels and grab the screen when it's your turn. And so on my list here, Sarah and David are up first. Or I guess David and Joshua, sorry.
Thank you, Zachary. Let's see. Does this come through?
I think it's getting there, yep.
Is it up now?
Yes.
Ah, okay. That's interesting. I don't see it in the ESCO window, but I'm glad everybody else does. And this is on my screen up higher, so sorry I'll be looking up into space here, which is a funny thing about my setup. Anyway, thank you for having us. So Josh, Sarah, and I have developed a MOOC on edX associated with a textbook we've been working on. This was driven by a bunch of different factors. One was the need last summer to suddenly pivot to online learning, and another was an effort to try to make this material available to a much broader audience. We think there were a bunch of successes and then some places where we're not sure whether we like this or not. So lightning version, our learning objectives are pretty standard. Digital design and computer architecture course going from 0 to 1 and then building a RISC-V processor. We've divided this MOOC into two halves. The first on the digital design, the second on computer architecture. Harvey Mudd's curriculum is so compressed that we have to cover both of them in one semester. UNLV spreads this over a little bit more time, and many places have a luxury of going into more depth over more time. Students get a take-home lab kit with a SparkFun RISC-V microprocessor, a breadboard, bag of chips, and get to build some neat stuff. The MOOC has 72 videos in the first part, on average about 8 to 9 minutes. Each video is followed by 1 to 3 practice questions. I think Jeffrey's point about this frequent low-stakes assessment is really high impact on learning. And that's a place where we think this MOOC was quite successful, that students see a short video and then immediately get to check if they understand the main idea. And then students do a series of labs, breadboarding a full ladder, then working in model sim, building an ALU decoder, doing state machines, and then the multi-cycle processor controller. The second half on computer architecture, it's a pretty similar set of arrangements, and we have 4 labs in C and assembly language on the RISC-V processor, and then they build their multi-cycle processor in Verilog, tying in with the first half of the course. We have been using edX at Harvey Mudd and Canvas at UNLV, and these are all a ton of work to set up the questions. Thankfully, we didn't have to write generators, but it was still a huge amount of effort to get the course up. They can do the different kinds. Well, they host videos pretty nicely. We have captioning on the videos. They accept a variety of questions, not quite as nice as what Jeffrey had, but certainly multiple choice questions and some free response questions that we can have students give each other peer feedback and then assess themselves. Drag and drop questions have been an interesting medium for asking different kinds of information. We found creating the figures, though, for these drag and drop pretty time consuming. And the thought of making generators for the figures is a really interesting question. So setting up this MOOC was extremely time consuming for us, but running it second time obviously is much easier. There have been some issues with software licensing. We found it difficult for many of our students who we thought would be quite technically savvy to set up ModelSim and Visual Studio Code on their own computers. Some of this was students running computers that were far more obsolete than we would have expected out of this audience. And some students just having a lot of difficulty installing common software. The evaluations are slightly lower than what we got in person, which I think was a pretty good success given the challenges of online learning. And we repeated the course second time this spring and got about the same results with a lot less effort. So overall, students got far higher scores, and we think that's a combination of the kinds of things that you can ask in a MOOC. Students get 2 choices, and like Jeffrey saw, the students have a bounded set of things to learn. They know what they're expected to learn, and they can learn it until they perform well on it. But we also think they may have actually learned more by having these bite-sized lectures and the immediate chance to practice it. We think it worked pretty well as an online format. Got feedback from the students. They didn't like having the instant feedback on the tests and problem sets, which was a bit surprising to me. So on the problem sets and labs, they get an immediate score, they get a second chance on every question, and then they get their final score. And they said they felt like every problem set and lab became an exam this way. They didn't like it that they didn't have partial credit, even though their overall grades were far higher. Many students reported a challenge of staying motivated with the online learning, and we had the challenges getting software up and running remotely. So we're going to keep this material available as associated with the textbook and create a self-paced version of the course. The Harvey Mudd schedule is so fast, it's difficult for somebody working remotely on their own to try to keep up with the course on this pace. So we'll bifurcate into a self-paced version and then a version that we'll continue to use in our Harvey Mudd class. That's the Lightning version.
Okay, yep. So I think we'll just keep moving through the lightning talks and save the questions kind of all at once for a larger discussion. So go ahead, Ellen, when you're ready. Yeah, you're still muted, Ellen.
Okay, thank you. I'm going to be sharing a video, and I'm hoping that the sound comes through. Did the sound come through? Okay. Oh.
I think we're hearing it now. I mean, I can hear your clicks.
Okay, sorry about this. Okay, do you see my presentation?
Yes.
Hello, I'm Ellen Spurtis. I teach computer architecture at Mills, a minority-serving women's college in Oakland, California. During the pandemic, I had to figure out how to teach computer architecture online while still giving my students the close interactive experience that they expected. Inspired by the book Grading for Equity, I decided to make the class self-paced with no late assignment penalties and to use mastery-based grading, which I describe in a separate paper. For the hardware lab, I assembled inexpensive components that I could ship to students.
We just lost the audio.
The rest of this presentation. One best practice for active learning is guided questions. These are asked before a reading assignment or lecture. The purpose is to get students to begin thinking about the content. This increases engagement with the material. Answering the questions helps the students think and learn, and it provides an opportunity for the teacher and student to communicate when the teacher responds to the student's answer. Here's an example. The first lecture asks and provides an answer for the question, what is a computer? Before the lecture, students are instructed to take a few minutes to think about and give a definition of a computer. I don't want them to spend too much time on it, but I do want them to think about it. What they write really doesn't matter. What matters is that they've thought about the question and they'll be more receptive and interested in what the lecture says. Another best practice is to provide students with interactive questions. Here's some examples of slides seen by the students. I've removed the audio and video of myself that they normally see. Here, I've explained AND gates and given them one to play with from Circuitverse. They can toggle the inputs to see how the output changes. They also need to fill in the table in order to advance to the next slide. I'll fill these in with the, well, maybe I'll make a mistake. Click the check mark. Lets me try again. And then I can advance. Next, we have a series about Carnot maps. After being given an explanation in video by me, the student is asked to take values from a truth table to a Carnot map. This should be a 0 if I enter a 1. Oops. I skipped ahead to the next slide where they're asked to drag this red enclosure around the largest region. I'll do that. And now they're asked to choose the product for the region. And I'll choose a wrong answer. No, the formula wouldn't include A because A is sometimes 0, sometimes 1 in the region. And now I'll choose the correct answer, B. I'm being prompted to choose the remaining region. A common mistake is just to enclose the single 1. While that region does include the remaining 1, it's not the biggest region that does so. So the correct answer, of course, is to enclose both of these. And now the student can type the product or click on help if they don't know what to do. Of course, this lightning talk is just a teaser. You can also see the full presentation, which has more examples, and it's not an MP4, it's an interactive storyline story. You can see the paper, which has more details and the outcomes, including the student survey results. There's a website that has all of the material with a Creative Commons license. You can edit the lectures, so it's your video instead of mine, but everything else is the same if you want to keep it. And finally, there's a Canvas website where there's quiz banks, and there's a free course that I started. I did a soft launch, and I'm making it available to people around the world who want to learn computer architecture.
Okay, all set, Ellen? All right. So this is kind of interesting since we had to switch up a little bit. I'm presenting in my own session, but so be it. All right. Do I have? Let's see, are you seeing the slides? Okay, you are. Okay, good, because I'm seeing Ellen. All right, so Ellen and I worked together on a paper talking about our experience implementing some pieces of mastery-based learning. Ellen actually did a lot of what's typical mastery-based, and I just had a kind of small piece on my projects. So I'm not going to say a whole lot about this, but I assume most of us who teach courses do what we call, or I call, a pile of points. Your final grade is just a bunch of weighted averages of tests, homeworks, labs, and projects. And there are some pretty obvious limitations to that. The thing that came up in the keynote, and especially in Ellen's part of the paper, is isn't enough incentive to keep working toward mastery after you take that first test, and it just doesn't go well. Depending on how much weight the final exam has or how cumulative it is. And at least I find it difficult to keep homeworks and labs very formative, tied in with the weights, right? If you have 5% of the grade being homework, students don't take it real seriously unless you get a little heavy-handed on the grading, and I don't want to be heavy-handed on the grading on homework. So you put these three things together and it just works kind of okay. So the idea of mastery-based grading helps address some of this because we're focusing on the learning outcomes, not the points. We're keeping track of what exactly have you mastered. Can you do the combinatorial circuits? Can you do the assembly language? And an explicit list of that rather than it just all getting lumped together in some average. And as we talked about or as Jeff talked about in the keynote, we want students to have multiple opportunities to demonstrate mastery. So it's not just take a test once and, well, oops, it didn't go well. Take the test again 2, 3, 4 times until you get that check mark. And then at the end of the semester, we can look back at what the students have actually mastered. Now, if you read the literature, the big picture literature on mastery-based grading, we don't want the soft skills to count toward the grade. So they'll say we don't want to factor in attendance, class participation, and timeliness. Well, we found that that's a nice idea in theory, but especially the timeliness aspect has some practical problems that we're still working on. So there's some obvious challenges. If you're going to give multiple attempts, you need the time to create the assessments, grade the assessments. The automation is the key. So Ellen had some tools she put together. Jeff obviously has some tools he puts together. And so I think those will get refined and developed over time. A lot of people interested in that. And our big open question that we're still both kind of tweaking every semester is how we handle the soft skills, how you reinforce that those soft skills, especially timeliness, are important without being too heavy-handed on that. Right, so some pieces here of Ellen's system. And then I haven't yet dove in fully into the mastery-based grading. I think I want to head that direction this fall or winter. I had been doing something like this in my projects for the past few years before I even learned what mastery-based grading was. And the other piece that comes along with that, not directly tied to mastery-based grading, but I've been doing a test-driven development workflow because I want the students to not only get everything to work, but I want them to be able to take charge of testing their own stuff, not just beating against the automated tests that I put out there. And so I have also some tooling behind that I can talk about as people are interested. Okay. So with that, we now have plenty of time to have a discussion, questions and answers. If somebody else has something they've been working on that's relevant in this space, feel free to jump in for a minute or two and tell us about it. And okay, so Ed already has a question he wanted to ask David. how did you recruit students for the MOOC? You know, what kind of participation are you getting outside of the Harvey Mudd community?
Josh, do you want to address that? Because you got most of those students.
Sure. Yeah, so it was a pretty small number for this spring. So last fall, we ran it purely internally as kind of the first beta test. And then this spring was the first time we opened it up broader than that. It was on the order of, so a lot of students joined the course, but only a handful finished it. So I think the average enrollment, if I remember the numbers, was something like 600, 700 students at the beginning of the course. But then the students that actually carried the digital design course through to the end were maybe only a dozen or several tens. And we think that's mostly due to the pacing, the fact that it wasn't self-paced. So that was kind of our main learning from that, and why we're planning to go to self-paced for the external students.
Well, that's what other people have reported with MOOCs, right? That the completion rate is in the single digits. So that shouldn't surprise us. And indeed, I've started a few MOOCs, but I've never finished any as a student myself. So, if I'm typical, then it's no wonder. So the other thing that I'd like to ask is that typically one feels more of an obligation to one's paying students on campus. So how do you, how do you divide the attention you provide to students between your on-campus students and students on the MOOC?
So moving forward, we plan to bifurcate the course to a self-paced version that is on the MOOC available to the world, and then the Harvey Mudd version that continues at our fast pace that we need and has a lot more interaction with the labs, with the weekly face-to-face time with proctoring and so forth. And realistically, we're not going to be able to give a lot of attention to the MOOC students. We're going to take out the questions that require much interaction, that require any sort of instructor grading, and just make it a resource to complement the textbook.
Okay, right. So how much of it is auto-graded, though? If it's auto-graded, then you can do it, and something like Prairie Learn would be ideal for that kind of situation.
Right now, it's over 90% auto-graded. There's a set of questions where students grade each other that I think we'll take out for the self-paced version. And there's one lab question where we give students feedback on their coding style from the instructor. And we'll also take that out for the self-paced version.
Okay. So I had a question for Ellen. So I thought that the examples in your paper and the video were kind of interesting. How long does it take to put those together? Are those, they look like it would take quite a while.
That's true. My first 75-minute lecture, I converted to 4 or 5 mini lectures, and that took a week to do. My speed increased as I learned the system, but it still takes time. Basically, it was my summer project last summer, and I didn't finish all of it during the summer. I had to do it into the school year.
So I wonder
So I also had to, I'd also like to ask Ellen the same question I asked David. How many external students did you get? How did you recruit them?
Do any of you know about Code in Place? It's a Stanford program that started during the pandemic. This was the second year. They teach the first half of their CS1 course online for free around the world. And they recruited 1,000 section leaders. I was one, and 10,000 students. And at the end of that, I posted on the board, hey, I have this free computer architecture class, if any of you want to give it a try. And I have about 20 students now. And after seeing how it goes and how much time I have, I might announce it to a wider group.
So,
Um,
so is Jeff still on? I wasn't sure if he had somewhere else to be. I know because Jeff mentioned the idea of mastery-based grading, yet switched over to just the weighted grades of the test with multiple retakes. I think there's some interesting discussions to be had here between, the unlimited retakes, or what others like about the idea of that mastery base, the checks versus trying to come up with, is combinatorial circuits 10% of the class or 12% of the class and whatnot.
Well, you have to, we have to provide a semester grade at the end. So we
Right.
need a way of converting the mastery-based grade to a letter grade.
Right.
So
But
I once heard Arnold. How many of you know Arnold Pears, the Australian who's taught in Sweden for years?
okay.
He said that in Sweden, I don't know if he said everything is mastery graded, but so they allow students to take exams as often as they want, but they cannot pass the exam until they get 100%. And so, it seems like that would be more time consuming on the instructor's part, but better for credentialing the knowledge of students.
That reminds me of something I did for the assembly language grading. That was manual, and in order to get an A, or 4 out of 4, you had to convert a complex function into assembly language. But if you wanted a 2 out of 4 or a C, you only needed to convert a leaf function into assembly language. But in either case, it had to be 100%, and you got to keep trying until you got it right. Unfortunately, that wasn't automated. I had to create the questions and grade them by hand. But
Yeah.
I have small enough classes that's
Right.
faster to do than build an automated system.
Oh, that's certainly true. If you have single digit numbers of students, the best exams to give them are oral, right? Because it takes no time to prepare and you can probe whatever you want. But if you've got over a few hundred, then the most efficient exams to give are multiple choice because it's perfectly autogradable. Problem with multiple choice in general, though, is that it's very hard to figure out who cheated. And so not only for the pedagogical reasons, but also for the security reasons, I don't like it at all.
Well, Zachary has the best of both worlds with a project and automated testing. So it's not multiple choice, but it's scalable.
So I see Jared's question. I'll come back to that in a minute. But on this topic, and again, tied into something that was going on in the chat at the end of the keynote, is with like the assembly language questions, I had been over the years trying to pare them down so they focus on one particular thing. Can you set up an if statement? Can you set up a loop? Can you access an array? Because when I had the bigger ones, it was really getting onerous to try to assign the appropriate partial credit. And then if you're having trouble with one spot, then it might obscure what you knew in another spot. But with the retakes, you can go back to the more complicated problems. And if there's a problem in the middle that's overflowing, then they just fix that and they take it again, and you don't have to nitpick that partial credit. So, and what led to that was the question of, well, how do you come up with a broad enough set of assembly language questions? Like if I'm focusing on if statements, there's about 8 combinations of if else before it really gets repetitive. But in some sense, you don't have to worry about that if you have the flexibility to make things more complicated.
Well, that also raises the question of why are we asking them to convert programs into assembly? We're not expecting them to go out and be assembly language programmers. What concepts do we want to, and skills do we want to make sure they get? For me, an important one was procedure calls, and that they really see by tracing through execution the difference between recursion, tail recursion, and iteration in terms of reinforcing the data structure and algorithms concepts.
Right. And then for me, I don't want them to be human compilers. I just want them to see that they have a good sense of what their source code looks and feels like when it actually hits the hardware.
Yeah, spinning that link between the hardware and the high-level language, I think is really important to understanding the topic. But I could jump to a question about the lack of deadlines in this mastery-based learning model. That seems to run contrary to most human nature. If a student were in my class with no deadlines and all the other classes had deadlines,
Yes.
most human beings that I know would put off the non-deadline thing. And
Right.
then
That
would pile up at the end and the learning would be poor because the work's all piled up at the end. Don't the deadlines play an important role in spreading the learning across time?
that's exactly the problem that I ran into. So when I'm doing my projects, I give them, they have 2 weeks. So they get a timeliness grade, and which is a large chunk of it. So if it works on what the initial deadline, they get 100 out of 100. You know, there's style points in there and so on. But if it works, they get full credit, and they lose a few points every day up until the end of 2 weeks, because I can't run my course if I'm getting everybody's work in the last week of class, and the students do need that carrot and stick. And you're right. I think the biggest issue is if I'm the only one with that much flexibility, I end up at the bottom of the pile because I'm not urgent, regardless of how important it is.
Another issue, I agree with everything that was said. Another issue is the other teachers aren't doing the same things. And if students have assignments due with strict deadlines in their other classes, not to mention their jobs and other responsibilities, my class is going to go to the bottom. Let's make sure that Jared and Charlie's question gets answered.
Yeah. Yep. And yeah, I'll start by saying that is one of my concerns, and part of the reason that I haven't jumped fully into mastery-based grading yet, although after hearing more about it over the last few weeks, I'm feeling a little bit better about it, is because there are some things that where I'm not really just looking for them to solve problems. How do you demonstrate that you understand the trade-offs between a split and a unified cache? You know, that's not a, I can't think of problems that demonstrate that. I want a small essay. Well, there's only, one way to write that question. I don't want students to memorize the answer to that question. That doesn't mean anything. So yeah, that is something I've been struggling with.
Yeah, me too. Specifically, I only have one version of the questions of how you'd modify a data path to add another instruction, and comparing the cache performance of different programs. You know, the latter especially is really important because our students will be programmers, not computer architects. And I don't know how to test well on that.
Yeah. So returning to the issue of mastery grading versus just standard grading, we do mastery grading because it benefits students who are perhaps underprepared and get a chance to retake things. But it actually also hurts them because students like that may be more inclined to procrastinate or a little bit more diffident about their ability to take the assessment. So they may postpone the first attempt until it's too late. And I'm wondering if we can think of a way to marry those two strategies, you know, the ability, the need to get things done on time and the ability to retake, so that we can get the best of both worlds and the students who have lower preparation actually do succeed, without making the system so complicated that people don't understand it.
Yeah, I agree with the problem you identify. I surveyed my students afterwards and asked what late policy would be preferred by them. And they did not choose the no late penalty ones. That what they liked most was when they'd have a limited number of tokens, a small number rather than a large number, where a token could be used to turn in an assignment one day late. So I still haven't decided what I'm going to do for the fall, but even, I don't know if they would have recognized it before taking my course, but after taking the course, students recognized that total freedom from deadlines wasn't best.
And, you know, I think that the token approach is very interesting. The problem I would have is I don't think my LMS would implement it. And I'd be faced with manually implementing it, which you can do in a small course, but not when you have over 100 students.
Yep.
So, and in general, with the innovative grading strategies that I've invented in my life, they are not supported by LMSs.
So I faced the same question about extensions in the fall of the pandemic. And due to the pandemic, I wanted to be receptive to the students' needs and grant an extension anytime that it was requested. But it's too much work to keep in the LMS. So I ended up just relying on our honor code. And Harvey Mudd has a pretty strong honor code, and I think that worked fairly well for us. But I don't know how to generalize that to school where students might be less reliable on an honor code.
Well, there certainly is. You know, I think that would be that the whole idea of how to blend mastery learning with the need to set some kind of deadline would be a really good subject for an IU's proposal. And I don't know if I could do that in any of my classes, but, you know, I think it would be great to collaborate on something like that, because IU's really is about benefiting all students' learning. And if we can put mastery learning in so that we can get the students to actually finish the course, then there's going to be a big benefit to it. And also, it's something that seems like you'd need some technology support to do it with reasonable effort on your part. And so piecing together the different components, you know, the grade book and the question generator and the delivery mechanism, that would be very interesting. You could maybe build on something like Prairie Learn or a similar tool.
So I've heard mastery-based learning is really catching on with our math department, especially in calculus and some of our discrete courses. And apparently Canvas does a pretty good job of supporting the different aspects of mastery-based grading. That doesn't help me, but you know that Canvas is popular enough that I think that would address some of the concerns for maybe half of our audience here, and I would hope the others would follow soon on if they recognize the benefits. Jared kind of added to what he was saying. He said, well, if a student has memorized something, doesn't that mean they've learned it? Well, okay, we know that that's kind of iffy, right? What you really want to do, especially if this is a 3 and 4, junior, senior level course, is not ask for something you've memorized, but ask a contextual question. Here's a situation. Now, how do you apply what you've learned? And I think in phrasing the question, his comment that way, Jared has really hit the nail on the head, where I think the tough spot for me is going to be is it takes me years. Maybe once a year I come up with a really good context question that highlights the key issues. And so I've got a library of 6 of these questions, and I guard them really closely so that they're not out there in a library for students. And then now I want to go to a system where I can give students 2 or 3 retakes. You know, those two goals are in conflict. So yeah, Jared's got the right solution. You want to be asking application questions, but man, I am not good at writing those. Maybe what we need is, as a community, to work on a library where all 20 of us brainstorm and come up with a library of these questions, and then somehow keep the students out of it.
Yeah, that's true. And I had a CCLI grant to do something like that, computer architecture course database 20 years ago. And we ended up with, I don't know, we ended up with 130 users of which 8 actually contributed questions or something like that. So this was before the days when you could, you know, automatically administer them and with particular variants. But it was good for a while. It just though I was finding that a lot of the problems didn't have enough context for me to use them, or they may relate to somebody covering something in a different order than I do. So I think it's a really good idea, and I know that there have been other attempts to develop reusable problem libraries, and I don't think they've gotten too far. Doing that for an automated testing system, excuse me, where you would share problem generate or question generators, I think that might be a little bit more promising approach. Yeah. But even then, you might have problems with, you know, it assuming that you covered this before that, and you actually covered them in the other order.
That's actually the big problem. There's a number of libraries. People have tried 2 or 3 different libraries of assignments, generally focusing on CS1 and CS2. And that's where I run into trouble, is I can't triage those. I try to look at a 1-paragraph summary of the problems, but there's all those little details that come into the suitability, and it takes me almost as long to find a problem in that library as it would be for me to write it up myself. So that context, that metadata is the challenge.
You know, that's the same kind of challenge that people are working on in search engines, right? You know, natural language search. So if we applied existing technology, we might get a little bit, or applied new technology, we might get a little bit farther on it.
So the author doesn't have to annotate. I like that idea. Okay. I'll have to talk to our machine learning people here.
Okay.
I've been struggling with some of the questions of sharing and scalability as well. I'd love this idea of sharing libraries and sharing generators, but there's so much work creating this and then a lot of work maintaining it. We ended up going with the edX platform because we thought it would provide an audience for the work we've done. While if I just put something on my own site, the number of people who steer towards it might be small. But the downside of edX is it costs $150 for a student to take the course, which is really not my intent. It steers all the profit from this to a profit-making entity and out from the notion of open source or from rewarding the creators. I don't really have an answer of how to wrestle with that. If we're investing a lot of work into these generators, for instance, and sharing generators, then how do we sustain it and encourage people, reward people, make it accessible?
Yeah, good question. My question generators are available on GitHub. If anyone wants to build on those, they're just Python scripts that create text that's suitable for importing into Canvas. You know, they're not as elaborate as the Prairie Learning questions.
Another thing that's becoming popular is the flipped classroom. And in that context, a very complete set of high quality videos like what David and Joshua have put together could be really valuable, because it just doesn't scale for each of us to do our own. So maybe an easier question is how to reasonably compensate those who are putting together those high quality videos. And that might be a little easier to do at a price students are willing to pay. I can't have my students, you know, pay $150 for David's MOOC, but I might be able to talk them into $5 to get access to another set of videos, which are inevitably going to be better than mine.
Or for the NSF, or
SIGARC to fund it.
Yeah, and the
Right.
$150 is coming from edX, essentially as a fee for hosting their service. But we still own the videos, and we'd be happy to give them away to anybody who wants to use them at no charge.
Oh, great. Yeah, so I just talked yesterday with one of my students, PhD student, who is teaching a class this summer. He's teaching, I think it's C and software tools, which actually is close enough to computer organization. But anyway, he's using videos from the instructor that teaches the course in the regular academic year, and he's having trouble adapting. And I remember that one time I did something like that when I taught a C course. I just was teaching other courses a semester, didn't have a chance to redo my own, so I used a lot of materials from the other instructor. And there's a difference between making your own and using somebody else's.
Yeah.
If you make your own and somebody asks you a question about it, you can answer it. If you're using somebody else's and somebody asks a question, it's like, why did he say that? And so I also have the experience of using Armando Fox's and Dave Patterson's videos from their SaaS software as a service course in a non-architecture course I teach. And that has actually worked very well. They have good videos and they have good resources. And we don't use all of their resources because our students are a little bit more advanced than they're keying for, but it's a great way to get the course started. And every video they have has a little problem session that goes along with it. So it is possible, but it's not without its hiccups.
Right. What I've seen is there's a huge difference. You're right. I mean, that is a problem in general, but there is a huge difference between somebody who has pointed a camera at their whiteboard or recorded their lecture as they've given it for 10 years and something like an intentionally designed from the ground up set of videos like with the MOOC. Mm-hmm. But yeah. Even with something as good as the MOOC, you're right, there is still going to be some rough edges on that. It might be an interesting research problem. How can we put together the videos with just that amount of flexibility to take some of those rough edges off?
Mm-hmm. Yeah, I agree.
So it is 11 o'clock. We have a couple minutes if there's any burning questions. If not, it's probably a good time to stretch your legs, take a break. And so anybody have anything last minute?
There's a question in the chat from Matthias about the time.
Oh, that's right. Thank you.
Yeah. So I was spending probably 70 hours a week during the first half of the semester and 50 hours a week during the second half deploying the MOOC during the pandemic. That's not something from a family perspective that I could sustain in the future. So I view it as a one-time pandemic thing. But developing a MOOC with just Sarah and me recording videos is it would take a larger institutional effort over a longer time to do in the future.
Okay, well, we'll be back at 10 after the hour for our mentoring panel. See you then.